these problems out of the worksheet that I gave you on Thursday. I guess I gave it to you on Wednesday, but I asked you to have these done on Thursday, have them done on Friday. Starting on question 13. The one thing that I think is important to understand here, guys, is that this is a practice of retention, meaning can we retain and then reproduce the information that we've talked about in previous chapters to address current situations. Okay? In order to solve for W, I need to know something about this triangle here and the fact that it's a what kind of triangle? Isosceles. And this segment here, drawn from the vertex angle perpendicular to the base, does what to this 120? Bisects it. So W is 60 whatever units. Is that okay with everybody? Okay. If it's isosceles, does this 42 transfer to right there? Okay, so the idea, guys, is that they're going to hide that type of information to you so that you can transfer values, develop values, so that you can eventually set up something like this. Does that now look like questions 1 through 6? Yeah, that's a traditional Math Excel, do you understand SOHCAHTOA question? Okay? But these worksheets, I think, are a little bit more difficult, a little bit more rigorous than Math Excel. So what side is Z in comparison to 42 degrees? Opposite. What side is 60? Adjacent. So which trig ratio are you going to use? Tangent. Yep. So I'll say tangent of 42 is equal to opposite over adjacent. And then I'll cross multiply. I'll get 60. Tangent of 42 is equal to Z. And that gives me approximately 54. 54.02 is up 2 decimal places. That's something we can do? Okay. So on test or quiz, and I think you guys saw it on Friday, you know, there are a couple questions on a test or a quiz that are just like questions 1 through 6, where just solve for one distance, just solve for one angle measurement. Very simplistic SOHCAHTOA. But then there's going to be questions that ask you to build concepts on top of one another and use a 30-60-90 with the SOHCAHTOA question, or a 30-60-90 with a 45-90, or something like that, to where you're stacking ideas together to come up with something, because that's what the end-of-course exam asks you to do. The end-of-course exam is not going to give you a question like, like 1 through 6 here. Okay? They're going to give you questions like 13 through 18. But they're probably not even going to give you questions like 13 through 18. They're probably going to give you a question maybe like this, where you use ideas that are created in 13 through 18, but then they give you a scenario that allows you to develop that picture. Does that make sense? More like something like this. Okay? You got a scenario here, a story problem, and it generates this triangle right here that looks like something that we might see in questions 13 through 18, or something like this. Does that make sense? Okay? So that's kind of your end-of-course exam type questions, but seeing 13 through 18 like this is hopefully trying to get us to develop that skill that once we do see a story problem, once we create the picture, we can then address it. Okay? So kind of building that procedure. Okay? What about this one? What kind of triangle is that overall triangle? Isosceles. So this distance here is going to be W as well, isn't it? Okay. So can I find W that way? Can I look at that angle? 200 is what side? Opposite. W is adjacent. Can I say tangent of 35 is equal to 200 over W? Okay, when you cross multiply and solve for W, really what happens is that the W and the tangent of 35 just switch spots. So you get something like that. I think W ends up being 285-ish. And then Z is how much of W? 2 of them. Because again, if this is an isosceles triangle overall, this segment bisects the opposite side, right? Bisects the side that's perpendicular to. So W is half of that. double it, you should get Z. So this becomes like 571.25 or something like that. So those little relationships of like doubling or taking half of were established in chapter 4. Okay, and the authors of these books, the authors of these tests are going to assume that because we're at the end of the year, we've seen chapter 4, we should have mastered chapter 4, we should be able to use that information. Okay, it's all you all have all that information learned, and you displayed that you learned it at some point. It's now just a matter of, have I developed the schematics in my mind to be able to organize my thoughts, to pull and reference that information quickly, okay? Instead of having to maybe search through notes and all that kind of stuff. I made a comparison earlier today. If I take your book bags, okay? And there's probably people in this classroom that are like this. You take your book bag, and it's just a collection bin for you for papers, books, and you just throw it all in there. Somebody gives you a paper, you just put it in there. No organization. So then when I come to class in a week and I ask you, get out that packet, get out that worksheet, you have a really, really hard time of finding it, right? But I know some of you are in here that have color-coded folders and notebooks for each class and that kind of thing, and I give you a worksheet, you know exactly where to find it 3 months from now. Okay, does that make sense? You organize your brain the same way when you're learning stuff, okay? If you take the time to develop that kind of filing system when you're learning something initially, it is going to be so much easier 3 months, 4 months, a year, 2 years from now to pull that information back out. Okay? It's all there. Can we pull it out and use it? Okay? So that's something to think about as you're learning something. Okay? How important is this information going to be for the future? Because that might then tell me how I store it in my mind. Okay? And then the tools and strategies I use to store it in my mind. Look at this triangle. Okay? What jumps off the page right away?
That's a triangle.
Okay. 30, 60, 90 should jump off the page. Okay. What they're trying to get you to do here is realize that this is your 2 in side. Across from 90 degrees is always 2 in. This side would be in root 3, and W would be your inside. You got to remember it. Okay. And that's the thing, guys. People came up to me at the end of the class on Friday and said, I didn't do well in that because I can't remember which side's in radical 3. Well, that's just something you got to remember, guys. That's something. If you can't remember that, that's on you because it's just a picture to ingrain or embed in your mind so that you can come up with it. Okay. And you had your notes. Okay. All right. So 2 in is 150. So what's n going to be? What's n going to be? 75. So that would be this side, right? Does that now, using 30, 60, 90 triangles, does that allow you to get into this triangle over here? And we're trying to find Z. 75 is what side? Opposite. Z is adjacent. So again, we're going to use tangent. Now, we don't always use tangent. Sine, cosine do show up. Just on this worksheet, they don't show up very often. So tangent of 40 is 75 over Z. So then I'll have Z to be 75 divided by tangent of 40. Equates out to be 89.4. Okay. Now, you could have done the same thing in that triangle on the left using SOHCAHTOA because they're asking me for W, which is the 75. If I use SOHCAHTOA, it'd be sine of 30 is equal to W over 150, and then I go 150 sine of 30. It will spit back 75. But if for some reason they wanted me to use the n radical 3 side, the n radical 3 side with SOHCAHTOA is going to give me a decimal, right? Not a number like 75. Therefore, they would probably want me to use special right triangles instead of SOHCAHTOA. Okay? And that's another thing that I saw a lot of people struggling with on the quiz, is that there are, and especially in the homework as well, is that there are questions that are designed based on the instructions of what tool you're going to use. Because SOHCAHTOA will work for every single right triangle. The 30, 60, 90 template, the 45, 45, 90 template only works for 2 sets of triangles, right? So when they have directions that say leave your answer in simplest radical form, they're giving you a hint there. Even though they don't say it in the directions, they're giving you a hint there. Use special right triangles. Use 30, 60, 90, 45, 45, 90s. Okay? If they say round to 1 decimal place, 2 decimal places, they're telling you, I don't care what approach you use. You want to use special right triangles, use that. You want to use SOHCAHTOA, use it. Okay? Doesn't matter. But the directions or the way you got to write your answer dictates a lot of times the way you need to approach it. Yes?
Can you use P theorem?
Pythagorean theorem?
Yeah. Can you use that on every triangle?
Every right triangle.
Oh, I got that wrong.
If you have 2 sides, you can find a third one.
Right.
Okay. Okay, so this one, a couple different ways I've seen people doing this one. How do you guys think we should do this?
Oh, you find out the 30, 60, 90 question.
Okay, so, all right, so now you can't do it, but you can redraw, all right? So I'm just gonna hide this stuff because now if I look at that triangle, it's a 30, 60, 90 triangle. Across from 30 is always in. Hypotenuse is 2, and I don't really care about the hypotenuse in this question. And this is my n radical 3, right? There's my equation. I'll have 900 is equal to n radical 3, right? Divide both sides by what? Radical 3. Okay, so I get 900 over root 3 is equal to n, but I don't like to write it that way. So I'll multiply by that, right? So it's going to be 900 radical 3 over 3, and I think you're seeing the benefit of doing that. What's that 900 over 3 going to change to? 300 radical 3, right? Does that make sense? So that is this distance of W, 300 radical 3. Okay? Now, let's come back and see what we can do to solve for Z. I'm solving for Z. I'm going to redraw my picture, so I'm just dealing with that triangle. Okay? Now remember, Z is just up to, like right there, right? So if I'm looking at this triangle that has this 42-degree angle in it, what is 900? What side is that? Opposite. What side is this? Okay, Z plus 300 radical 3, but it's the adjacent side, right? Okay. Can I say that do some blue, that the tangent of 42 is equal to 900 divided by Z plus 300 radical 3? That make sense? It's opposite over adjacent, right? Now it's an understanding of our algebra. Okay? If I cross multiply, what's 1 times 900? 900. Okay? Now, when we cross multiply our extremes, that number right there is just a number. It's like 0.9004. Okay? Times Z would be 0.9004Z, right? But 0.9004 is rounded. I don't want to round it. So what I'm going to do is when I multiply those, I'm just going to write it as Z tangent of 42. Is that okay? That still says 0.9004Z. Now I'm going to take that tangent of 42 and multiply it by that number. Now both those are actually symbols for different numbers, right? Okay? One's like an X and the other one's a Y. Well, if I were to multiply X and Y together, I'd get just XY, right? That's the way we would write it. So here's the same thing. Because I don't know what the numbers that those things represent, I'm just going to write down the implied multiplication. 300 radical 3 times tangent of 42. It's actually, it's more like cryptic, it's more abstract to look at, but it's easier to do because I didn't really have to do any multiplication, right? I just wrote down that I want my audience to multiply that eventually. Just don't do it now. Does that make sense? Okay. Now I got to solve for Z, right? So you get Z by itself. I want to try to get Z by itself. I'm going to isolate this term first. So what do I need to do? So this is just this is three numbers being multiplied together. So it's like 300, 1.7, and 0.9 multiplied together. That would equate out to one number, right? One product. What would you do to both sides with that one value? Subtract it. Now, I don't want to, like I said, I don't want to rewrite and figure out what that number is. I'm going to leave it this way. So subtract 300 radical 3 tangent of 42 is now equal to z divided by tangent of 42. Now, how do I get z by itself? Good. Divide both sides by tangent 42, and that will isolate z. Does that make sense? Now, here's the thing, guys. When we're doing work with symbols, just like you do with variables, okay, you imply things like subtraction and multiplication and division if they're not like terms. 300 radical 3 and tangent 42 are not like terms. So I'm not going to multiply them, right? If it was like 300 radical 3 and radical 2, absolutely I'm going to change that to 300 radical 6. But tangent 42 is not a radical, so I'm not going to combine it with 30 radical 3 and condense it into one object. Does that make sense? And those are little practices of algebra that we have to be able to pay attention to. Would you guys agree that's a lot of work for that question? You know what would stink?
You got it wrong.
If I got it wrong after I did all that work. Because my calculator will make this wrong if I don't know how to use it. Okay? So here's what I want you to understand. All right, so if I've got, let me clear all this out. Oh, that's pain in the butt. There you go. Seriously? Will that work? Do I have a reset button here? Oh, good, Alex. All right, so, all right. What we're looking at then, if I type in, you messed my calculator up bad.
It's taking longer than you just pressing fingers. I mean, it's obviously mine. All you gotta do is press the little button on the back.
All right, so we're looking at, if I were to type in 900 minus 300 square root of 3, okay, tangent trying to use my keyboard, it doesn't always want to work right. 42, tangent 42, and then divide a tangent of 42. Okay, my hopes are we understand what governs our calculator, what governs that evaluation. I'm going to get it wrong if I type it in that way. Okay, I got to change it to degree too. But isn't that thing, PEMDAS, what's going to govern how this thing is evaluated? And remember how those work, okay, how our order of operation works. It says look inside the parentheses. So it makes us look inside a set of parentheses, and then once we look inside the set of parentheses, we run through PEMDAS again, right? Every single time that you do an operation, you then regenerate PEMDAS again and redo it. Does that make sense? It's like a new problem. So what's going to happen here, Obviously, because there's nothing to do inside those parentheses, that's actually a kind of a trivial object. Where there are no exponents, we get to multiply and divide left to right, correct? My calculator is going to do that multiplication first. Does that make sense? It's going to store that value, wherever 300 radical 3 is as a decimal, it's going to store it. And it's going to then rewrite 900 minus that number times tangent of 42 divided by tangent of 42. Does that make sense? And so you're going to take whatever this number was here, because it's going to look like this. That's 900 minus a new number times tangent of 42 divided by tangent of 42. So what it's going to do then is go through order of operation with this new expression, and it's going to do multiplication, division as it sees it left to right. So it's going to do that, right? And it's going to evaluate that and come up with a new number. Now I got 900 minus this new number, then divided by tangent of 42. And it's going to go through then the order of operations again, and now I get division, and it's going to do that division. Does that make sense to everybody? So here's what I want you to understand. The thing that is getting divided by tangent of 42, the thing that is getting divided by the tangent of 42 was this number here, which essentially turns out, if we work our way backwards, turns out to be that product. That is the only thing in that blue box, that is the only thing that gets divided by tangent of 42. But look at how we wrote it by hand down here. What gets divided by tangent of 42? The whole thing, the 900 as well. So if I go ahead and hit enter here, I get 380, and I know nothing about what type of answer I'm supposed to get, so I assume that that's a correct answer. Does that make sense? When in contrast, it's the wrong answer, because I did not divide the 900 by tangent of 42 as well. So what I need to do to fix that on these calculators, and this is, you might be like, oh, well, I'm not using TI 8384. Well, if you're using one of those smaller ones, it's the same programming, same order of operations. I need to put a parenthesis there and a parenthesis there, because what do parentheses do? It tells us to focus on that expression, run through your order of operations through that over and over and over again until you get that down to one value, right? Then take that one value and divide it by tangent of 42, and that should give you a number close to like 479. Okay? Does that make sense to everybody? Okay? There are other approaches to this question, but regardless of the approach, you're going to get 479.936. Yes?
I just want you to know that I'm sorry about saying this.
That's okay. Easy to delete. Okay? Yes?
Isn't it like so much more confusing than that? I took the same way. Like I used the biggest triangle and then like took the top value and then changed it from the right.
Okay.
And I put V plus W over 900 because I had what W was, and I took like, and I had V plus 900 over tangent of 60 over 900.
Did you get the right answer? Yeah. Awesome. Okay, so she's telling me she used that angle 48. Okay, somebody else earlier today did this. They knew that this was 300 root 3. They found this first. They said, now I want to take tangent of 42 is equal to 900 over x, right? And they said, oh yeah, 900 over tangent of 42 would equate to that x. Does that make sense? And they knew that this was 300 radical 3, so they took 900 divided by tangent of 42 minus 300 root 3. And their argument was, well, that's completely different than what you wrote, Mr. Fay. That's exactly what I wrote. Because what I wrote in red was one fraction, wasn't it? That's two fractions, isn't it? What do I need? If I want to subtract those two fractions, what would I need? What do you need for any two fractions that you can subtract?
Both the numerator and the denominator.
And that denominator has to be common, okay? So my common denominator here would be tangent 42. If I multiply that 300 radical 3 by tangent 42 over tangent 42, it gives me exactly what I had written in red by looking at that smaller triangle, that 3069 triangle first, and then looking at the overall one. Their argument was, well, I looked at the overall one first, and then the 306090. You arrive at the same conclusion. Now, looking at the 48-degree angle, obviously you're not going to write down the same stuff that I wrote down. You're going to have, obviously, numerators and denominators kind of switched up a little bit, but it will work out to give you the right answer. Is that all right? Okay. So it's about, what did it say, 479? I think that's the hardest question on here. But, I mean, those are like ACT-type questions, and I think the ACT, a lot of their questions on there are, in regards to their rigor, how hard they are, parallels well with how hard the end-of-course exam is. Okay? Told the last couple classes today, that test, guys, and we're getting closer to it, it's the first week of May, that test is difficult. All right? And I'm trying to get you to realize that they're not going to give you a question like number 1 or 2 on that end-of-course exam. It's not Math Excel type questions. They're these type of questions where we're using things that we should have picked up. So the Math Excel stuff kind of gets us to focus on learning the kind of bare minimum information, right? And then the worksheets and stuff like that try to help us build additional concepts so that we can address those harder questions that are going to show up on the end-of-course exam. Yes?
So, I just want to math, but I wasn't sure I asked my son, I wasn't sure if you wanted to put your name into the rotisserie chicken raffle for my birthday.
No, I'm good. Thanks, so.
Put your name 3 times.
Okay.
Bring your rotisserie chicken.
Just email me.
I don't know how to do that.
I've noticed. All right, so this question here, 20. We talked on Thursday that a grade of a road, do you remember what we said the grade of a road simply was? Grade equals slope as a percentage, right? Okay. Now, in this problem, we run into an issue. They tell me I have this road. So my road is the hypotenuse, right? It is increasing at an 8-degree angle. If I'm going to find slope, isn't slope rise over run? Do I have that here? No. But what I do have is that 8 degrees, which is very important to me. And my rise being the opposite side of that 8 degrees, and my run being the adjacent side of that 8 degrees, right? Does that make sense? Okay. Now, if this is opposite, I'm going to call this y, I'm going to call this x. Would you guys agree that tangent of 8 is equal to y over x? Opposite over adjacent, right? Here's the thing. I don't have any numerical values for x or y. But whatever they are, okay, let's look at x and y in, let me do this, let me put these in black. Y and x for the black triangle, and y and x for the red triangle. Because they are both in a right triangle that have an 8-degree angle in it, would you agree that the y and x that are black would divide to be the same ratio as the y and x that are red? Does that make sense, everybody? And we talk about that because those two triangles are similar, right? Okay? Any right triangle has an 8-degree angle in it. It has to be similar to any other right triangle that has an 8-degree angle in it. So the opposite divided by the adjacent of that 8-degree angle is always going to be the same ratio. So what does that mean to me? It means that when I choose x and y, it doesn't matter what one of those are, okay, or what one of them is, okay? You could choose y to be some number, any number you want it to be, and then you can use the tangent of 8, which is the scale factor that's going to help you find x. Does that make sense? Or you can let x be any number you want, and then you can use the tangent of 8 as a scale factor to tell you what y is. I think it makes sense, and like I said, it doesn't matter, but I think visually it makes sense to say, if I'm working at that as being 8 degrees, this is y, let's let x be 100. Okay, so it might be 100 feet, 100 meters, whatever the unit is. Would you agree that tangent of 8 is equal to y over 100? Can I then say 100 tangent of 8 is equal to y? And what that's going to do is going to give me my incline, well, not my incline, but my, let's say, my elevation. Kind of hate that this calculator turns off about every 30 seconds. If I go 100 tangent of 8, okay, it gives me that 14.05 number. That's my rise. Does that make sense? When I go 100 feet out, I've risen 14.05 feet. Okay? Well, rise over run would then be that number divided by the run, right? That's my rise divided by a run of 100. I get that. Okay, so that's my rise over run. That's my slope of my road, right? Turn it to a percentage, 14%, isn't it? Okay. Now, what I want you to see is the idea that you say, oh, well, you chose 100, Mr. Fay, so how do I know to choose 100? If you understand the relationship between sine, cosine, and tangent in this measurement here, it shouldn't matter what you chose here. Give me another number. 67. I heard a 7. Give me another number. 15. Okay? And I heard 8 as well. So let's say that distance was that. The only thing that would change is that they would become 67.7158 tangent of 8 would give me that y, right? Does that make sense? So this is the scale. Is this scale factor the same scale factor that was right here? Tangent 8 that scale factor, right? If I type that in, 67.7158 tangent of 8 gives me that. So what it means is if I go out 67.7158 feet horizontally, that means I've risen 9.5168 feet vertically. Does that make sense? Well, rise over run, this is your rise. That number is your rise, so I'm going to divide that by the 67.7158 number, and what do I get? I get the same exact 14.05408.347 I got when I used 100, right? So it shows you that it doesn't matter what you use as your run. When you use tangent of 8, coupled with that, your rise will always be scaled the same way, so that your slope then will always be the same. Does that make sense? Okay. You could do the same thing with the rise and then find the run. Okay, so choose any number that you want your vertical increase to be, and then you can find out then how far you got to go horizontally to achieve that. I like that question. That question targets several concepts, and one of the things that I think is very important is that they kind of hinder you with just giving you one number, right? Okay, if they gave you two numbers, you would probably zoom right through that. Giving you one number forces you to know mathematical concepts, okay, to allow you to generate those others. So we have to have, to be able to do that problem, we have to have a good understanding what sine, cosine, and tangent are doing for us and what they really mean. Let's skip this one. 21, skip that. Let's go to this one. Diagonals of a rhombus. What do you know the diagonals of a rhombus do? Okay, so I'm hearing all the right things. Okay. There's one thing that they do that I did not hear, though.
They make right angles.
That's what perpendicular means.
Oh, is that right?
Well, yeah, but somebody already said that.
They are congruent. The same way.
All right, so this thing here, rhombus, right? Okay. If I take a diagonal, okay, so say that's my diagonal, right? Well, let's phrase this first. Look at this angle. Would you agree? How does that angle right there compare to that one? How does A compare to D? Okay, they're supplementary. Okay. In terms of size, which one's bigger? Which one? Name it. A is bigger, right? Okay. So which diagonal is going to be bigger? This one or the dotted one?
That one.
B to D. Okay? So the horizontal one's going to be bigger, because this angle here is bigger than that one, right? So when they say you have an angle that's 70 degrees, does it make sense it has to be that one? This one would be 110 in my picture. Does that make sense? Okay. This would be the shorter diagonal because it's across from the smaller angle. The longer diagonal would be across from the longer angle or larger angle. Does that make sense, everybody? Okay. Those are all facts that we have to be able to understand, and they are true. We can prove them using previous information. Okay. So the red diagonal is actually the one that we're being asked to find here. They tell me the black one is 122 centimeters. Okay. They tell me this angle here is 70 degrees. We need to know what the diagonals of a rhombus do to opposite angles. Bisect them. So that angle is two 35-degree angles, right? What would this say? If this is 110, what is that angle right there? 55. Okay? Hopefully you knew those pieces of information, and then what happens here? If I couldn't remember the property of the theorem that we know about the diagonals, we're left with 90 degrees left over for that third angle, right? Okay? So, we've got that information. What else do the diagonals of a rhombus do to one another? They bisect each other. So A to M would be how big? Or it should be 61. Okay? So does that generate then a question like 1 through 6, where if this is 35, this is 61, can I find X? That makes sense? Okay? Or I prefer actually to look at the 55 up here, because now if I go, this is opposite, and this is adjacent, right? It's going to say tangent of 55 is equal to X over 61. Multiply both sides by 61, and I've got my X value. If you use the 35, you should end up with 61 divided by tangent 35. What would I do with that number then to find the red diagonal? We just found D to M. So what do I do with that number to find the red diagonal? I double it. Okay. A to M is 61. Okay. So this is point D, and that would be M there. We found that distance. So if I could double this, so I could either evaluate, I could type that in my calculator and hit enter, and then times 2, right? Could I just say 61 times 2 and get 122, and then tangent 55? Okay, now we'll get me the same value then for that red diagonal. Is that something we can do? Okay. Now, what was encapsulated in that problem? I cannot address that problem if I don't know what the diagonals of a rhombus do, right? And there's a lot of things they do. They bisect opposite angles. They bisect each other. They're perpendicular. Okay, there's a lot of stuff that we need to know about the diagonals of a rhombus in order to address that problem. Okay? And, of course, exam. We'll use parallelogram properties to hide information to you. They're not going to give you the right angle there. They're going to tell you got diagonals of rhombus. Okay? And we need to be able to pull out that information. I cannot wait until after May. And I can stop saying, and of course, exam does this, does that. I'm sure you're tired of me saying it, right? Okay? But I hopefully drive that point home to you of how important that test is.
Wait, do we have one next year?
Huh?
Do we have one next year?
No, unless you don't do so well on this one, you don't get your 5 points.
Isn't it just the government one?
Okay, so you got to remember what you did last year on your algebra. Okay? And then you need to make up the extra points here this year on your geometry. Okay, so 27. I want to jump to this one. All right, if I were to take last class struggled with this. Let's see if I can actually do this real quick.
You okay?
Why is this class? Why do you think this class is hard?
No, this class is easy.
This class is easy. Because you don't pay attention.
I do pay attention. I answered everything in here. Besides him. So, check this out. Check this out. For 5. Because it was hard. I literally got it done in like 15 minutes. Yeah, I got it done in like 40 today. Perfect. That's all. I'll work you him up. Because I don't know how to do attitude.
So here's this is what boggles my mind. People tell me this class is hard. Algebra came so simple to me. What were you supposed to learn in algebra?
No, I
What are you assholes?
I don't remember.
What you said you can't do.
I did good in algebra though. I think we did one like section about radicals, and I didn't. That and.
I think that I just get a lot of people that which I understand you're 15, 16-year-old people, which I understand this. I was the same way. But I think we have a bad interpretation of ourselves in regards to what we know and what we don't know. And I think we say that I really know algebra, I'm really good at algebra, but when I assess your geometry skills through your algebra, usually you set your geometry up right. But it's the algebra that you struggle with. Okay? But then it's the same concept or the same token. When I ask you what you prefer the algebra, even though that's the thing that you're not that great at. Does that make sense? Like I ask questions about how do I add fractions, how do I subtract fractions and multiply and that kind of stuff, and I don't get answers. That's algebra.
I know.
Okay. Yes.
Can I go after this quote the out press, please?
No.
Miss Cole, can you go out the press? We did not hear you.
All right. So guys, this is kind of what I was talking about in the last class, but they were kind of struggling with this concept. Look at that shaded triangle, right? If I look at angle D, because this is a two-dimensional shape, two-dimensional surface with a three-dimensional shape as the rendered image, right? Okay? That's what they're trying to portray to us. If I put a protractor on top of this thing, I don't know if I can make that protractor bigger. There we go. All right, guys, so if I this is kind of what's going on here. If I were to look at this angle here, at angle D, do you see that right now it is showing me, how do I get to the... So this is going through, let me zoom back out. All right, do you see how this is going through like 117 here? And this is going through like 180, okay? If I subtract those, that does not give me 90, correct? Okay? I'm probably going to get, if I could do this correctly, I'm going to get, ultimately, it's showing 29. I'm going to get the supplement of 29. This angle here is the 29 that it's giving me, I believe, or whatever. But I'm going to get this angle right here. That is an obtuse angle. Does that make sense? Okay. But when I've actually got this shape in my hands, is that angle, which is right now at angle D, is it really an obtuse angle? No, because it's now just that right triangle, correct? So it's a right angle, but the perspective that I'm getting when I look at it this way on the worksheet is that it's not a right angle, right? I think the people that are missing this are missing that idea. That's a right angle right there, okay? When I look at this thing from the bottom, it's a rectangle, right? That side's 4. What's this side down here? 4. This side here is 3. What's this side here? 3. So you have two triangles there that are 3, and then 4, and then the red side would be 5, right? So the hypotenuse of that triangle, that right triangle, is 5. Now, why is that important? Let's get rid of the prism. The prism is 5. The prism, when I get rid of it, we know that distance from D to B is now 5, right? They told me the height of the prism in the picture was 2. Can we now find this angle down here? Yeah. So if I go tangent of angle B is equal to 2 over 5. 2 there. Can I take tangent inverse? of 2/5 to give me B. And when I type in tangent inverse of 2/5, second tangent, 2 divided by 5, 21.801, right? Look at what GeoGebra is telling me that angle is. 21.8. Okay, and I've got it rounded to different decimal places, all that kind of stuff. But do you see that idea? We were able to go through using that picture, that rendering on the worksheet, put all that information in GeoGebra. GeoGebra's doing the algebra, doing the distance formula, all that kind of stuff, SOHCAHTOA, all that stuff, and it's getting the same answers that we got by hand. Okay?
Well, that was one of the easier than 18.
I would agree with that. I agree with that. But the hard part of that one, I think, was because most people miss that is because they can't figure out that that's 5 because they don't know that bottom triangle down there is a right triangle, that white one down there. All right, guys, your homework tonight. I sent it out in an email. Check your email. Don't respond to it. There is a PowerPoint that we're going to start tomorrow, but I need you to learn half of it on your own tonight for homework. Okay? There's really 2 slides in there that's got a lot of vocabulary on it that I need you to know that vocab when you come to class tomorrow. We might do something to make sure that you know it.
Yeah. Like another quiz.